Have you ever wondered how one man's thoughts could redefine our understanding of the universe? Nestled in the annals of history is one such individual, a true enigma, who went by the name of Albert Einstein. Born in the late 19th century, Einstein was not your average child. The compass his father gifted him at age 5 sparked a curiosity that would fuel his lifelong passion for understanding the mysteries of the universe. Einstein, a man who marched to the beat of his own drum, was often at odds with the traditional education system. Yet, he never let it quash his thirst for knowledge. His audacious ideas and groundbreaking theories catapulted him to the forefront of the physics world, forever altering the trajectory of science as we know it. His influence is imprinted in everything, from the tiniest quantum particles to the vast expanses of the cosmos. Without Einstein, our comprehension of the universe might have been vastly different. The year 1905 was a landmark in the history of physics, largely due to a young patent clerk in Switzerland. This unassuming individual, Albert Einstein, was about to send shockwaves through the scientific community. Despite his day job, Einstein found time to pen 4 groundbreaking papers that year, each one more revolutionary than the last. The first paper, titled On a Heuristic Viewpoint Concerning the Production and Transformation of Light, proposed a new concept that came to be known as the photoelectric effect. This theory suggested that light behaves as if it is made up of particles or quanta, challenging the long-held belief that light was purely a wave phenomenon. Einstein's audacious proposal earned him the Nobel Prize in Physics in 1921. The second paper, On the Motion of Small Particles Suspended in a Stationary Liquid, as required by the molecular kinetic theory of heat, provided the first definitive proof of atoms' existence. Before this, atoms were largely theoretical, but Einstein's explanation of Brownian motion put any doubts to rest. His third paper, On the Electrodynamics of Moving Bodies, introduced the world to the theory of special relativity. Here, Einstein proposed that the laws of physics are the same for all non-accelerating observers, and that the speed of light is the same no matter what speed or direction the observer is moving. This was a radical departure from Newtonian mechanics and forever changed our understanding of time and space. Finally, in his fourth paper, Does the Inertia of a Body Depend Upon Its Energy Content?, Einstein proposed the most famous equation of all time, E equals mc squared. With this, he demonstrated that mass and energy are interchangeable, setting the stage for advancements in nuclear physics. Einstein's Annus Mirabilis, or miracle year, was indeed miraculous. It laid the foundation for the modern era of physics. These 4 papers changed our understanding of the universe and remain as relevant today as they were over a century ago. Einstein's Annus Mirabilis laid the foundation for the modern era of physics. A decade after his miracle year, Einstein was not done reshaping the field of physics. In the year 1915, Einstein's relentless pursuit of knowledge led him to expand upon his already groundbreaking special theory of relativity. The result was a new magnum opus, the general theory of relativity. Let's dive into this concept a bit more. Where the special theory of relativity described the physics of motion at constant speed, the general theory of relativity ventured into a more complex territory. It sought to explain the behavior of objects accelerating due to gravity. But Einstein's genius didn't stop at merely explaining gravity. He revolutionized our understanding of it. Einstein proposed that gravity was not just a force that pulled objects towards each other, as Sir Isaac Newton had famously suggested. Instead, he introduced the idea that gravity was the result of the curvature of space and time, a concept now known as spacetime. Imagine a stretched rubber sheet. When you place a heavy ball on it, the sheet dips under the weight, creating a curve. Now, if you roll a smaller ball near the heavy one, it will move towards it, not because of a mysterious force pulling it, but because of the curve the heavy ball created. This is a simplified analogy of how Einstein viewed gravity. This radical viewpoint transformed our perception of the universe. It suggested that the Earth moves around the Sun not because of an invisible force pulling it, but because the Sun's mass distorts space-time, creating a sort of well that the Earth rolls around. Einstein's general theory of relativity also predicted the existence of black holes, cosmic objects so dense that not even light can escape their gravitational pull. It also predicted gravitational waves, ripples in space-time caused by the movement of massive objects. With the general theory of relativity, Einstein had once again turned the world of physics on its head. His insights continue to guide us as we strive to unravel the mysteries of the universe. Einstein's legacy is indeed a testament to the transformative power of curiosity and intellect. Now, let's delve into the realm of the very small, where Einstein's work had unexpected consequences. The world of quantum mechanics, a field that explores the peculiar behavior of the tiniest particles in the universe, owes a great deal to Albert Einstein. Despite his well-known reservations about the inherent randomness and uncertainty of quantum mechanics, it's fascinating that one of his most significant contributions was in this very domain. In 1905, the same year he proposed the special theory of relativity, Einstein published a paper explaining the photoelectric effect. This phenomenon, where light shone on a material causes it to emit electrons, was puzzling scientists. Einstein proposed that light, previously thought of solely as a wave, also behaved like a particle. He introduced the concept of light quanta, now known as photons, packets of energy that could knock electrons off a material's surface. This groundbreaking work won Einstein the Nobel Prize in Physics in 1921. Moreover, it laid the groundwork for quantum mechanics, a field that would revolutionize our understanding of the microscopic world. Yet, as quantum mechanics evolved, Einstein found himself increasingly at odds with its direction. The theory's inherent unpredictability, encapsulated in Heisenberg's uncertainty principle, was a sticking point for Einstein. He famously declared, "God does not play dice with the universe," expressing his discomfort with the idea that the behavior of particles could only be predicted in probabilities. Despite his philosophical disagreements, Einstein's work was instrumental in shaping quantum mechanics. His photoelectric effect paper introduced the particle nature of light, a cornerstone of quantum theory. Ironically, the very theory he had reservations about would not exist without his pioneering work. Einstein may not have been entirely comfortable with quantum mechanics, but his contributions were crucial to its development. From the photoelectric effect to his debates on quantum theory's nature, Einstein's influence on the quantum realm is undeniable, proving once again his transformative impact on modern physics. Einstein's theories continue to shape our understanding of the universe, but how exactly do they impact us today? Well, let's start with something we use every day: Global Positioning System, or GPS. We take it for granted when we navigate our way to a new restaurant or track our morning run. But did you know that Einstein's theories of relativity are instrumental in its functioning? The GPS satellites orbiting Earth are moving fast and high above the Earth's surface. This combination of speed and altitude means that, according to Einstein's theory of relativity, time ticks slightly faster for these satellites than for us on the ground. Without accounting for this relative difference in time, your GPS location could be off by miles. But Einstein's fingerprints are not just on our earthly technologies, they're also shaping our understanding of the farthest reaches of the universe. When you see those stunning images of black holes, know that they're made possible by Einstein's theory of general relativity. This theory predicts that massive objects like black holes will warp the space around them, allowing us to detect their presence even from billions of light years away. And let's not forget about the ongoing search for dark matter. This mysterious substance, which we believe makes up about a quarter of our universe, continues to elude direct detection. But it's Einstein's theory of gravity that gives us the tools to infer its existence. By observing the way galaxies rotate, we can see that there's more gravity at work than can be accounted for by visible matter alone. And that extra gravity? We believe it's the pull of dark matter. So, whether you're navigating your local neighborhood or pondering the mysteries of the cosmos, you can thank Einstein for giving us the tools to explore and understand our world and beyond. Einstein's legacy remains strong, continuing to guide our exploration of the universe. Einstein once said, "The important thing is not to stop questioning." This sentiment, we found, is intrinsically woven into the fabric of his legacy. We journeyed through the transformative years of 1905 and 1915, witnessing firsthand the birth of special and general relativity, cornerstones of modern physics. We delved into the seemingly paradoxical world of quantum mechanics, a field Einstein himself helped pioneer, despite his reservations. His influence persists, as vibrant and significant as ever, shaping the way we perceive the universe and its intricate workings. It is this relentless pursuit of knowledge, this unquenchable curiosity, that we celebrate when we reflect on Einstein's legacy. If you find value in such journeys into the heart of science, consider subscribing to our channel. We are committed to sharing more such explorations, unpacking the mysteries of the universe, one video at a time. In the spirit of Einstein, never stop questioning. Until next time, keep exploring the universe of knowledge.